Hey students, 11.4, apply the Pythagorean theorem and its converse. Okay, so you guys have heard about the Pythagorean theorem. It's famous, it's used all the time, buildings, everywhere. Even this school use the Pythagorean theorem to get those 90-degree angles. So we're going to go through it real quick. The side opposite the 90-degree angle is the longest side. It's called the hypotenuse. All right, so you always have to know that. And the other two sides are called the legs. Normally they're different sizes. They can be the same. That would be a 45, 45, 90. But normally they are different sizes. Okay, so in words, the Pythagorean theorem says, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs, so the sum of these two, equals the square of the length of the hypotenuse. So this leg squared plus this leg squared equals the same length as the longest leg squared, okay? So just make it real simple. And it's very handy. It's something you're going to use all the time and see all the time. So we're going to start. We're going to use the Pythagorean theorem to find the unknown length. As long as you know two of them, you can find the third one. So you have to always remember the longest leg is across from the 90-degree angle. So we're going to use the formula, and you know it. Shorter leg plus the other leg equals the longest side, the c squared. So you make sure you fill in the right stuff. If you don't, then that's the only way that you can get this wrong. So for the legs, it does not matter which one's A and B, honestly. So they say B is 6. So we're looking for A squared. We say that B is 6 squared. So always put parentheses around. I do that because you're going to see later on we have word problems. So we're going to have a term. So it's always good to do that. And then C is 7 squared. So we know A squared plus 36 equals 7 squared is 49. Remember squaring, 7 times 7. Subtract 36. And A squared is 13. Okay, but we don't want A squared. We've got B, we've got C, we need A, not A squared. So if something's squared, how do you undo something squared? By now you should know that you're taking the square root and taking the square root. And I always have the plus and minus just to show you this one time. You would normally do that. The only reason I ignore the minus is because we are dealing with length, okay? You're dealing with length or age or things like that. You can't have a negative square root of 17. So the length of this is the square root of 13. I'm going to take my calculator real quick. If we wanted to put it as a decimal, I'm going to clear this out. So I'm going to look at square root. It's the blue here underneath. So I take second, get the square root, 13. Okay, enter it, and I get 3.605. So it's approximately, because it's not, because a radical goes on forever, so let me bring it down. It's approximately 3.6, but you can leave it as the square root of 13, but it helps to see. And you should know if the longest leg is 7 and the other one's 6, it can't be bigger than 7, okay? It has to be less than 7. The theorem says that the hypotenuse is the longest leg, so that absolutely makes sense. All right? I think you're going to find this a fairly easy, straightforward lesson. This is a word problem. You just have to watch me do it, not be intimidated by it. So I went through, because our print was kind of not that dark with the ink, so I made sure to go over certain things and make them stand out. So let's just read it. Always read the instructions. Okay, it's going to be the same on your tests and quizzes. You got to read. A right triangle has one leg that is 2 inches longer than the other leg. Okay, so that's the unknown. We can call this X. That's the first leg. The other leg is 2 inches longer. Call it X plus 2. When you 2 inches longer, you're just adding 2 to it. And the length of the hypotenuse is the square root of 10. So here they've drawn up, and it helps to draw, and I would do that if I was on a test. I would draw it and put the 90-degree and then put the square root of 10, and one length is x and one length is x plus 2. It does not matter on the legs which is which. Okay, so you know there's the basic theorem. So I'm going to work it out here even though it's worked out. So I know that one leg is x squared plus the other length is x plus 2. That's what I meant by putting the whole thing in parentheses, equals the square root of 10 squared. Okay, so instead of just having straightforward numbers, you have variables and you have terms. All right, so this just stays as it is, x squared. This is FOIL, so this, I'm going to put it over here, is x plus 2, which we've already done, times x plus 2. Okay, so we know foiling this is x squared, outer terms 2x, inside terms 2x, and then last terms 2 times 2 is 4. When we combine this together, it becomes x squared, 2x and 2x is 4x plus 4. Okay, so I'm going to just add x squared plus 4x plus 4. And then if I square a square root, it gets rid of it, and all I'm left with is 10. Okay, so actually, it's working out kind of nice. So don't be intimidated. The more you practice this, it will just become a piece of cake. So I combine like terms. I have 2x squared. So 1x squared and another 1x squared gives me 2x squared plus 4x plus 4 equals, plus 4 equals 10. All right, so we're getting closer and closer to solving it. I have to set it equal to 0 because it looks like it's going to be a quadratic. It's got a squared, an x, and a number. Okay, so always be looking for this quadratic form here. Ax squared plus bx plus c. Anytime you see that or some variation of it, set it equal to 0 and solve it. We've done the square root property. We've done quadratic formula in the previous sections. Factoring, all of this stuff. So 2x squared plus 4x, if I subtract 10 from 4, I get minus 6 equals 0. Okay? Before I factor any further, remember the rule is look for a GCF. 2 goes into all of the 3 terms. So I'm going to divide 2 out of them. I'm going to get x squared plus 2x minus half of 6 is 3 equals 0. It's much easier to factor when you simplify. Always simplify everything else. Okay? So now ignore the 2. Let's just get the factors. X and x, it can only be 3 and 1 plus 3 minus 1. Set them equal to 0. X minus 1 equals 0. X plus 3 equals 0. So my 2 solutions are a positive 1 and a negative 3. Okay. I can't have negative. Okay. If I put it in for x, negative 3 is not a solution. All right, so I'm going to ignore that. So the length, the smaller length is 1. The other one is 1 plus 2 is 3. And then the third length, the hypotenuse, we know is the square root of 10. So there you're checking in, and it makes sense. So we're going to go on to another word problem. This one's pretty straightforward. They love to use these. So let's go ahead and look at the setup. It's talking about a soccer player. For those who play soccer, it should be real easy. So here we go. A soccer player makes a corner kick to another player as shown. To the nearest yard, how far does the player kick the ball? Okay, so you look here, you got your 90-degree. This is 12 yards, this is 40 yards, so he's kicking from here to here, basically. Okay, so as soon as you see that, you know that you can use the Pythagorean theorem. So you are looking for the hypotenuse. So look, you've got multiple choice, guys. So common sense, we can eliminate one right off the bat. because we know that the hypotenuse is the longest leg. So if one of the legs is 12 and one is 40, it has to be bigger than 40. I know straight away it's not 7. Okay? Could it be 38? No, because there's a 40 here, so it can't even be that. So I already know before I've started. That's the great thing about multiple choice, guys. You can eliminate stuff. So it can only be 42 or 52 because both of them are bigger than 40. So let's go ahead and plug in. I'm just going to leave this because you can follow along. So c squared is the one we're looking for. A squared they put as 12 squared plus 40 squared. 12 squared 144 plus 1600. When you add that together, you get 1744, but that's c squared. So we don't want c squared, we need the actual length. So it makes sense to give it as a whole number if it's a perfect square or a decimal. So when you take the square root of 1744, this length is 42, and that makes sense. So I knew it could only be C or D, and it is C. Now these things are real easy. This is converse, which means kind of the opposite. You're flipping it around. So the converse of the Pythagorean theorem states, if a triangle has sides lengths A and B and C, such that A squared plus B squared equals C squared, then it is a right triangle. Okay, so we are going to look at that and see whether something is a right triangle, but just the fact that they give us numbers and we can test them. So tell whether the triangle with the given lengths, side length is a right triangle. So okay, so look at this. So you know you've got 3 numbers, 8, 15, and 7. So of course, which one has to be the hypotenuse if it's going to be? It has to be the bigger number. C would have to be 17. So you work backwards, call 8A, 15B, and the hypotenuse has to be 17. Square them. 8 squared is 64, plus 15 squared is 225, and then 17 squared is 289. Add 64 and 225, and you get 289. So, do they equal each other? Yes, it is a right triangle. Okay? So again, let's look here. 9, you got 5, 8, and 9. 9 has to be the hypotenuse. 5 and 8 are A and B, it does not matter. So we're calling 5A, 8B, and C has to be 9. So 5 squared is 25, plus 8 squared is 64, and then 9 squared is 81. Add 25 and 64 and you get 89. Does 89 equal 81? No, it's not a triangle. So that's how you can tell if they're not equal to each other, then it can't be a right triangle, because the theorem states that the sum of the legs squared equals the hypotenuse squared. That's the converse. You're working with numbers, you're just plugging them in. It either is or it isn't. So here they take a word problem and use it in the converse. So it says a construction worker is making sure one corner of the foundation of a house is a right triangle. So he needs a right triangle. To do this, the worker must make a mark 8 feet from the corner along one wall. So call that 8. And then 6 feet from the same corner. So call that 6. And then the worker then measures the distance between the 2 marks. So here, and he says it's 10. So he wants to know if this corner right here, so draw it out, always draw it out when they give me stuff. And don't worry about my drawing, I'm not a very good artist. The main thing is that you know what you're doing and you set something up. So these are my 2 shorter legs. It doesn't matter which one's A, which one's B. So 8 squared plus 6 squared, does it equal 10 squared? 64, 6 squared is 36. Equals 10 squared is 100. 100 equals 100. So yes, he's got the right measurements, and that's all it takes. So guys, hopefully this helps. Pythagorean theorem, I think, is a nice, easy lesson. Okay, I will see you again with the next lesson soon.